Yeah, we will do 8.5 after we do these. We're going to do them both today. So 8.6 is finding the area between curves that intersect at more than 2 points. So what we have here is we've got the area between the graphs of these two. Here we got a cubic function and a quadratic, and the graph here is given to you. So the problem with this is that you have two separate sections of intersections here. So whenever we look at this first part of the graph, the cubic is the function that is on the top, but the quadratic is on the bottom. Whereas over here, the quadratic is the top function and the cubic is the bottom function. So it's fairly simple what you're going to have to do for this. You need to find those intersection points, which thankfully we don't have to do much of here because it's given to us. And then you just basically need to treat it like two separate problems. So, which does mean it's going to take a little more work, but we can do it. So we're going to integrate this first part from our x value here is -2 to 0. And we will be integrating the top function, which is 3x to the third minus x squared minus 10x, minus the bottom function, which is our quadratic, -x squared plus 2x. So I'm just going to do this one piece at a time. So we're only looking at that left section. And so we would just distribute that negative and combine our like terms. So we'd have 3x cubed. X squares are going to cancel. And then we'll get minus 12x dx. I distributed that negative over here to that -2x. So I got -10x and a -2x that I put together to get that -12. Well, there's a negative right here. Where it was a plus 2x, and I distributed this negative that was here, which gave me that negative right there. All right, so to integrate that, we are going to do x to the 4th. We'll have 3/4 here, and then we'll get minus 6x squared. We will evaluate that from 0 to -2. So we'll have 3/4 0 to the 4th minus 6 times 0 squared. All of that's just going to equal 0. And then we'll have 3/4 -2 squared to the 4th minus 6 times -2 squared. So that'll be 16. 3/4 of 16 is 12. And then this is going to be 24. So -12, but then we got this negative out here, so we get positive 12 for that area. So our area over here is 12. Yes, always top minus bottom. It seems a little backwards to be plugging that 0 in first because most problems don't have the 0 plugged in first, but always top minus bottom. That's only half of it. We've got to turn around and do 0 to 2. And that will be our -x squared plus 2x minus 3x cubed minus x squared minus 10x. Probably. Unless they had some sort of intersection where they like just touch at one point, and Like if you had something that looked like this, maybe a sine function and something like that, where they intersect but they don't actually cross. So if you had something like this, you could integrate over the whole interval there. If they don't actually cross. But pretty much every time they cross, if they cross, you're going to have to integrate that section separately. So for this, yes. Because it's a quadratic, so we would know it would have to be this shape right here. The cubic is going to have to be the one that's got the two different turning points. Yeah. So if we distribute this negative right here, watch Daniel as I distribute the negative. It makes this negative, this positive right here. So we got negative 3x cubed. These will cancel. I'll get plus 12x here. It's going to be similar to our other part. I wonder if we're going to have the same area. They don't really look the same to me, but maybe they will be. So we're going to get negative 3/4 x to the 4th plus 6x squared this time. We must evaluate that from 0 to 2. So negative 3/4 times 2 to the 4th plus 6 times 2. I think it's going to be the same. Squared minus, I'm going to get 0 when I plug in 0 there. So we're going to get 12 plus negative 12 plus 24. So we'll get positive 12 for this part. So we'll get 24 for our final answer. I do not, but
It's not good. I still smell it. It still smells.
all right.
It's lotion.
Okay. Just Richie's propane lotion, not actual propane, so we do not need to evacuate the class.
Not yet.
Not yet. All right. Okay, I think this is a pretty neat problem. This would be calculator active, so I would suggest that you get out your calculator here. I would really love to just use Desmos on this because Desmos is much better, but we can't use Desmos on the exam. I wonder if AP has any plans to put theirs on the computer. I don't know. I know that obviously, like, there's not much advantage. The free response has to pretty much be on paper. So unless they give everybody iPads like Addison's to take the test on where you can actually write. Yours is
basically owns the whole Apple.
Yeah, it's yeah. He is very confident with it. Yeah, if you take it out.
I think I should
Thomas, you do not want to have to. But unless they want to give us all those, the free response has to be on paper anyway. So I don't know if it's just maybe easier for them to give the whole thing on paper than. And I know AP's given all around the world, so while pretty much most of the schools in the U.S. are going to have computers to use for testing, that might not be true in some places. That's a good question. I'm thinking they translate it to a lot of different languages. Because surely, because they give AP. Yeah, I don't now when I was in Mexico, whenever I did my little study abroad summer trip, the lady that I lived with, we went to one of her friend's house one night to eat dinner, and his job was to translate math books into Spanish. So, like, and they were like Prentice Hall, sort of like math books that, lots of people use. And his job was to translate those into Spanish. So he, like, brought it out and showed me some of the stuff that he was doing. I was like, this is so cool. This is, like, I'm not good enough at Spanish to actually do this, but this is, like, both of my majors, actually. You would actually use both of them if you could do this. But my Spanish is way too weak to do that. But it was a really cool job. Your two least favorite. Yeah. All right. Yeah. Lots of countries do teach English. It is probably your most common. Yeah. Oh. Well, most common, like in other, probably most common in other, like, there might be probably like the most number of other countries that speak it. We're just talking about number of people, then you're probably definitely not English, but I know there are a lot of, yeah, that stuff is crazy. We were watching a documentary on it the other day about the characters and because there's no alphabet. There's. Yeah, Laura. Yeah. Yeah. Even my husband was watching. My husband is pretty interested in like learning other languages right now. Right now. Yeah. He's got Duolingo on his phone. He's been teaching himself German. But he's interested in it. So the other day he was watching this like video about the Russian alphabet, and my little nephew who's in kindergarten was over there, and he was watching it, and they were going through all the letters, and he called me in there to watch it because they have like 36 letters, and they're crazy, and the guy was pronouncing them all, and half of them all sounded the same, and then there was like, I can't remember, I think it was an N and an H, I can't remember, and there was an N up on the screen, but then they made the H sound, and my little nephew, he said, he just called that N an H. That's silly. So, I don't think so. Kangaroo Jack. Is this a movie or a show? It's about a kangaroo. Yeah, I've not seen it. Is it good? Should I watch it? Yeah, it's funny. Is it a kids movie or a... PG-13. Okay. Okay. Just need to know whether or not the children should watch it or not. Okay. All right, let's look at this problem because I think this one's pretty neat. It is, so this came from, I don't know if it's still in this textbook, but we got these books 4 or 5 years ago, so they're fairly new. Before that, we had textbooks that were copyrighted in like 1995, and all of the problems in them were very, very, very old. So this came from that book. It's a really good problem, but it is super old because we're talking 1960 to 1979 and then post 1979. So it's a little ancient, but I think it would be really interesting to see the same patterns for today because I think you're seeing a lot of differences in fuel consumption patterns in society now because you have more fuel efficient vehicles and electric vehicles, but you also have a growing population, so it'd be interesting to see what's happening. But so from 1960 to 1979, this just linear equation is modeling the consumption in billions of barrels per day. Billions of barrels per day. Yeah. So then from in 1970, they looked at the data, or this textbook made up this problem where they looked at the data, and they changed the consumption model that they were using to be this cubic function right here. So we're supposed to find the total amount of fuel saved from 1979 to 1993 as a result of the fuel being consumed at the post 1997 rate. So let's put these both into our calculator. Okay. The question is, you're supposed to find the total amount of fuel saved from the 1979 through 1993, or from 1979 through 1993, as a result of the fuel being consumed at the post-1979 rate. Basically, post-1979 rate, that's the second equation. We got to find the difference between the two. So we're going to put these in. Yeah, the window's probably going to need some work. It should be on your paper.
Window to the interval that it's given on the paper.
You got to get your X's right before you do zoom fit. So we want to go from -10 to 23. Oh wait, I need an X right there. Okay. That's what my window looks like. Oh, not good. Not good. Alright, so when you do zoom fit, go to your window. Let's go -10 to +23 here.
Yeah, it looks pretty good. You can do the Y one to like 85 and get away with it.
Yeah. Alright, so I need, the problem with zoom fit on this one, you could use zoom fit, but I do like to still see my x-axis there, so. Yeah, so.
Like 80 something.
80 something should work. That's what Thomas is telling me.
I used 100 and it looks fine. I did 3. Yours looks different than mine does.
I think I actually, since we're really interested in like this part over here, I'm gonna actually make my window a little bit. I'm gonna maybe go like 40.
So I think you did it. I think you did it right, and I did it wrong. Really? All right, now we're talking.
All right, so I made my X go from -10 to 23, and then I did like -2 to 40 on my Y-axis. Oh, look at that. Oh, yeah. Okay. You typed one of yours in wrong. You need something to the third power. You might just have an x squared. Did you put your x's in? Did you use x instead of t? Don't put t's. Okay. I went negative 10 to 23 on the x-axis and negative 2 to 40. We are mostly concerned with positive 9 to 23. Because at positive 9, that would be the year 1979. All right, so I do need to know where these intersect. So on F5, anything you need to do from the graph is going to be from F5. We're going to go down here to intersection. So F5, number 5, which is intersection. First curve, second curve should do it correctly. Lower bound. Move to the right side for your upper bound. If you only have 2 in, it should just automatically switch to the other one and it should be okay.
I got the same numbers.
Yeah, so when it says first curve, click enter. When it says second curve, the little spider should jump up to the other line and click enter. And then the lower bound is really like your left bound. You want to be on the left side. Right bound, or upper bound is your right bound. Okay, so they intersect at 8.3365. So since I only care about from 9 to 23, I actually don't have to worry about that intersection right there. Uh-oh. I got 8.33655. Are others of you getting this? Make sure I haven't typed something in wrong for that intersection. Same thing. Uh-huh. Yes. So for this problem, it asks us to look at the amount of fuel saved from 1979 to 93. And in this case, for whatever reason, t equals 0 is 1970. So we just really need to see from 9 to 23 is what we'll be looking at. And since these intersect at 8, then we're starting over here on the right-hand side of that. So we're actually not going to have a switch in the intersection. Now, if they had asked us for, like 1970 to 1993, then we'd need to do 2 separate sections here. But this one, we just need to look from 9 to 23. And since we have our functions in y equals, we put this one in y1 and this one in y2. So we can just integrate from 9 to 23. And the top function is the line there, I think. Yeah. Yep, so that line, so if that line continued on and that was what you used the whole time, then you would have this area under the curve right here. But it's not. We're using this cubic function instead, which is lower. So to see the difference between those two, we can subtract. So we would have f of t minus g of t dt here would give us our answer. And if we go back to our main screen, we can integrate. And the good thing here is we have these in y equals. So we can just do y1 of x minus y2 of x, comma x, comma 9, comma 23. The graph is important to see which one is on top there. And you also need to check, like that intersection point, it did not fall between 9 and 23, so we didn't have to split it in half. But if it did fall between 9 and 23, we'd have to split. All right, so we get 30.4407. So it saved 30.4407 billion barrels of oil. It's not time to go. And let's see. Okay. All right.
Jack has a paper.
Jack, you disrupted
I cannot do that.
immature.
I just like literally, like I'm like just solving it.
Go to the office.
Okay, look at the other worksheet in chat. We are actually not going to do example 1. Well, actually, I'm sorry. Yes, we are. Hold on. I was thinking that was just a warm-up sort of example. Okay, so, you may, if nothing else, we might use it for the last part, so that we don't have to do all that arithmetic. So what we were doing yesterday is we were going from A to B. We were subtracting. So like if we wanted to find the area under the curve here, we would just integrate F minus G here. That would give us that yellow area there. But today we're going to see something different happen. So first of all, they have given us this equation in terms of y instead of x. So some of these will be completely calculator inactive. So let's think about what this graph looks like. Okay, so no, that was just.
It's just there.
So this is here. Normally we would be doing this on a separate day, and I would be reminding you that we did the top function minus the bottom. And then I would graph this next one and show you why that's not going to be as easy. All right, so
we don't have enough space to do that.
You may use a separate sheet of paper if you would like.
I'm just gonna make this.
So one thing you can do for these is to graph them, especially here, is what I would do. You could just solve this for y. This one's really easy to solve for y. Y equals x minus 1. So that is going to be, I'm going to use blue for this one. I know you don't have blue. Okay, and then to graph x equals 3 minus y squared, there's a couple things you can do. If you remember doing these from pre-cal, this is going to be a quadratic that is sideways, right? If it was x equals, it was a sideways parabola. Since y squared is negative, is it going to open to the right or to the left? It is going to open to the left, and it's going to be moved.
3 spaces up.
I think it's going to be through. I think it's going to be 3 spaces right. So because it's x equals, so it's backwards. So that number right there is going to move it this way. So all right. I will.
This is pre-cal. I'm not full of cap. This is not the only thing I remember from.
Okay. So another way, if you get stuck on knowing how, hopefully you can at least recognize it as a sideways parabola. But if you get stuck on this, you always have the option.
It's because x equals.
If you solve it for, another option you can solve it for y and use a square root function. If you do that, you're going to have y squared equals 3 minus x, and you'll square root both sides, but you'll need a plus or minus there. So it'll be because when you square root both sides, you have to put a plus or minus. Yeah. And you can't just omit the bottom. So you can do it that way, or you can plug numbers in. So if you plug in, for example, if you plug in for your y, if you plug in like 1, 3 minus 1 squared would give you, 3 minus 1 squared would give you 2, so that gives you the 0.21. If you plug in 2 for your y, 3 minus 2 squared is negative 1. If you plug in 3 minus 3 squared would be negative 6. We really don't want 3, actually. That's going in the wrong direction. Because remember, plugging in y values. So you would want, like, plug in 1. Hold on. I already plugged in 1. I don't know why that. Those aren't actually. Did I write those negatives?
Yeah, you did.
Oh, no. I'm plugging in y's. I plugged in 1, 2. I'm plugging. It's so backwards to plug numbers in for the y that I'm having trouble. I need to plug in 0 for the y. 3 minus 0 squared is 3. So the 3 goes over here. So 3, 0 is this point right here. You could plug in negative 1. 3 minus negative 1 squared would also give you 2. So you've got the point 2, negative 1. That's here. If you plug in negative 3, you're going to get 3 minus negative 3 squared. Well, I didn't do a negative 2, did I? Negative 2. Let's do negative 2 instead. That's what we really want to know. Negative 2. That's going to give me a negative 1 here. So that's this point right here. So you could also graph it like that. Sometimes these problems will give you the graph so you don't have to worry about it. Sometimes they may be calculator active, so you don't have to worry about it. But you might see these that are calculator inactive. So here's the problem. If we're going to do this in terms of x, we're doing top minus bottom, which will be okay right here from negative 2 up to 1. because we're doing the blue graph minus the red graph. It'll work out beautifully. What happens over here? That is itself, right? And if you just subtract the equation minus the equation, it's going to give you 0. So it's not going to find that area there. So instead of doing this problem with respect to x, we are instead going to do this problem with respect to y, which is actually easier because the equations were in terms of y from the beginning anyway. So whenever we integrate in terms of y, we need to think about which function is furthest to the right minus the one furthest to the left. Here. So we will be doing right minus left.
So it's like you looking at it like...
Yeah, you gotta like turn your head sideways when it's in terms of y. And a lot of times the equations themselves will be in terms of y, and that should be a alarm to you that you should use y's instead. So what we can do here is we can integrate. Furthest to the right is our red graph, which is 3 minus y squared. And then we would be subtracting furthest to the left, which is y plus 1. Okay, very good question, and this is what messes students up the most, what they make mistakes with. So it's -1 to +1. Those limits, since you're in terms of y, those limits have to come from your y-axis. So if you have a dy over here, which you need to write, don't leave it off, then your limits need to come from the y-axis. So your lowest point of intersection, did I say -1? I meant -2. Lowest point right here is -2, up to +1 is your highest point right here. It's you're thinking of, so the very lowest point where they intersect right here, the coordinates for that are -1, -2. So you're looking at that y coordinate. And then right here, that's at 2, 1. So you're looking at that y coordinate.
So it's basically exactly what it is.
Yeah, it's just like you got to turn your head sideways, and it's the same. And use y's instead. So we would go from -2 to +1. Now, once you get it set up, there's really no difference except for using the letter y instead of x. You're just integrating here. So we would be, let's combine these here. So we'd have -y squared minus y plus 2, because we'd have to distribute that negative there. If you distribute this there, you'll get a -1, and add it to that 3, you'll give you a +2.
Yeah, we got 3 existed.
Yeah, it's there. Probably.
Good.
Especially since it matters a lot whether or not you're integrating this with respect to. There is a way to integrate this with respect to x. It's much more difficult. So you could do it with respect to x, and they would still give you credit for it on the AP exam if you did it correctly. So if you put dx's here, they're going to act like you're trying to do it with dx's, even though you just wrote the wrong thing there. So try to be careful with those. So we're going to have 1/3 y to the third, -1/3 y to the third, minus 1/2 y squared plus 2y, and we will evaluate that from -2 to 1. And let's use the calculator for that.
So do you plug in the bottom number on the rule or the top one?
Top goes first. So we will do -1/3 times 1 to the third minus 1/2 times 1 squared. I'm not typing it in. Plus 2 times 1. So we're going to get, whenever we plug in the 1, we get 7/6. And then when we plug in the -2